Howdy, math neighbors. Friendly neighborhood calculus teacher back with a bonus topic 7 video. Remember, topic 7 is the potpourri topic. So, like, all kinds of things can happen. So, you can get a mixture of different stuff, which is what this problem is a really strong example of. So, this is an excellent problem. It is on the calculator permitted section. So when you try this, remember that you can use a calculator for everything. Don't be an algebra hero. Try to write as little as you can and enjoy yourself. I will go over my work next, and I'm going to assume that you have looked at your own work. So this potpourri question is really, really interesting because of the elements it incorporates. It incorporates a stem, so like a beginning of a problem, that's a table. And later on in the problem, it has an equation. And it has a Riemann sum, a follow-up question on a Riemann sum. It has a volume question, and it has a related rates question or an implicit differentiation question. Those are more or less interchangeable, I think, conceptually. Related rates is just a contextualized usage. But regardless, let's check out our work. Make sure we pay attention to the details. So the integral from 0 to 10, a of h dh is approximately equal to this with cubic feet. And we want to use a left Riemann sum, 3 subintervals indicated by the data to approximate the volume of the tank. I knew that the volume of the tank would be if I integrate the area, the horizontal cross section. So 0 to 2, that's my first one, base 2, left value, 2 to 5, 3, base is 3, height is 14.4, 5 to 10, 5 units base, 6.5 left value. Multiply those together, added them up, cubic feet, done. Letter B. We're looking at a Riemann sum, which means we will have an over or under approximation if the function is increasing or decreasing. So it has kind of the idea is that if you're a decreasing function and you're choosing a left sum, you're going to be choosing the 3 highest values. A right sum decreasing function, you choose the 3 lowest values. So that's one way you could think about how you know the difference between an over and under estimate. So a of h is decreasing on the interval 0 to 10. So we have an overestimate using the left Riemann sum. Not a whole lot more to say there. More of a, hey, remember this thing and remember that thing. And furthermore, remember that that's different from the trapezoidal thing, which because you're using secant lines has to do with the concavity of the function. Anyway, we want the volume of the tank. We have the area in square feet. So if I integrate area, I get volume. Really important thing to remember. This is related, but not the same thing as volumes of revolution and volumes of cross section. So those are still adding or integrating areas. We're adding or integrating area. The difference is we don't have to go out and figure out the function in order to do that. It's given to us. So we integrate from 0 to 10. We get this value right here in cubic feet. Part D, water is pumped into a tank. When the height of the water is 5 feet, the height is increasing. So I know that this is a positive 0.26 feet per minute. Using part C, find the rate at which, okay. So I chose to be a little bit lazy in how I wrote this, but you could definitely have gone after this a little bit more challenging. You could have written in what this equation is, I suppose. But here's the idea. Remember, the volume is this integral. And when you have a volume, when you have an integral and you differentiate the integral, they cancel out. They're gone. So you might be tempted to say, I've got f of h. But what you need to remember here is that the volume function starts at 0 and goes to some height h. So when I integrate, anti-differentiate, I sure get f of h, but remember, you have to multiply by the derivative of what you substitute in, because the chain rule is active. And then I have f of 0, and I multiply by the derivative of 0, which is 0. So this is another way you could think about this, as the fundamental theorem of calculus derivative. Anyway, I need the value of f at 5 times dh dt at 5, which I already knew, and that's cubic feet per minute. Scoring guidelines. 9 points total. Something that's interesting here, if you have correct units in parts A, C, and D, you get that first point. Now, I don't know how strongly that's linked to having the correct answers, but it just goes to show you the value of units. So for part A, we have a left Riemann sum approximation. Make sure you have the approximation in there. If you don't, that's no puntos. And you don't have to show like both of these. You can show one of these. Either of these is fine to show your left Riemann sum approximation. And then the value for part B, over estimate, we use a left Riemann sum on a decreasing function. Altogether, that's 1 point. Part C is 2 points. 1 point for the integral 0 to h, f of h dh. Make sure you have your dh on there. And then your answer, 101.325. Without the cubic feet, you wouldn't get that answer point. Part D, similar idea. So here's the function. They chose to write it with f of x. It's honestly doesn't, you could do h's, you could do t's. It just doesn't matter. They're just holding places. Regardless, when you take the derivative of an integral, you get the function, but you always have to remember to multiply by the derivative of the inside part. So here, a lot of students got no points because they didn't use the chain rule correctly. Pretty much you got 3 points here if you use the chain rule, because this arithmetic is not that sweaty because you'd have a calculator. This text here is unnecessary. It doesn't ask for an interpretation, it just asks for the value. So doing this with cubic feet to 3 decimal places is fine. Thanks for watching this bonus topic 7 video. Topic 7 is similar to topic 10, the BC series topic, because I could probably do videos for this from now until the end of history, and people would still want more videos, but I got other things to do. See you next time. Thanks for your attention.